This is the daily message for July 17th. Today we're going to continue working with the sampling distribution. So yesterday you simulated some data and you saw what a sampling distribution is. It's a plot of statistics. Today we're going to really start looking at how to use the sampling distribution. In other words, what information can we gain from it? And how we're going to do that is in the first worksheet, you're going to take the role of a researcher, and that researcher is trying to tell if two different parameters are different. And so in particular, the worksheet is set up telling you that you've taken this sample and you've got some bicycle accidents, and some of them occurred on roadways without bike lanes, some of them occurred on roadways with bike lanes. And then you're looking at the percentage of those two that ended up on trips to the ER. And so really what the researcher in this case is trying to do is they're going to be trying to figure out, does it really make a difference if a roadway has a bike lane or not in terms of the percents of accidents that lead in trips to the ER? Now, as we've already seen, getting the exact value of parameters is very difficult. So if we were trying to figure out if those two parameters are different, we can't really look at the value of the parameter. But what we could do is take two different statistics and compare those statistics and see if they differ to try to figure out if the parameters themselves differ. And what you're going to find out today is we have to be very careful. If we just use the statistics by themselves, we could make some incorrect conclusions. And so that's what the worksheet is going to lead you through today. What you're going to see is you're going to see a case if you had just compared two statistics by themselves, it looks like those parameters are really different. But what you're going to find is we actually really need to consider the two separate sampling distributions. What you're going to find out is there's really not much difference there and that the parameters really aren't different. And so this is why it's important when we talk about estimating parameters that we include the error in a statistic. And so you saw this in the previous Beyond the Number video when they talked about confidence intervals. So the work today is going to hopefully lead you into seeing how when you have a statistic and you're using a sampling distribution, this leads us into a very natural way into talking about confidence intervals and including the error with a particular statistic. Now, some things to keep in mind while working on the worksheets today. Remember that for this class when we're doing calculations, the parameters that we're working with are what we call population proportions. And so population proportions will always take a value between 0% and 100% because it's looking at the percentage of the time one of two options occurs. So for example, what percent of the population is male, what percent of the population is female? Those would be population proportions. So again, a population proportion always occurs between 0 and 100%, or in decimal form always occurs between 0 and 1. And the statistic we're using to estimate that parameter is what we call a sample proportion. So if you're asked what type of statistic you're looking at, it's a sample proportion. And again, since this is a proportion, sample proportions are always going to take values between 0% and 100%, or in decimal form, 0 to 1. And so the worksheet is going to ask you a couple questions like, what type of statistic are we working with? Well, it's a sample proportion. And then there's going to be another question that you'll see on one of them that's really checking to make sure that you understand that the thing you're trying to estimate, a population proportion, will always take some value between 0 and 1. And so if you make an estimate that says, hey, I think that population proportion is between, let's say -1 and 2, well, that's always going to be correct because the population proportion, again, can only take values between 0 and 1. So any interval greater than that is always going to contain the true value of the parameter. And like I said, that'll just be one of the ideas you'll come up with or that you'll see on the worksheets. But the worksheets are kind of designed to take you from the very beginning and start to help you develop these ideas of why when using statistics to estimate parameters, we really need to include the error in that estimate. And the sampling distribution is what tells us how much error we need to place on a statistic and eventually will help us build this idea of confidence intervals. So as always, if you have questions, feel free to ask and I will be around.